Welcome back once again. Today we're going to give examples for basic differentiation rules. And we have constant rule, constant multiple rule, power rule, addition and subtraction rule, and sine and cosine solving problems. So let's go. In constant rule, starting with constant rule, it is stated that derivative of a constant would always be zero. So for example, if I would have y is equals to 7 and we try to find the derivative of 7, it would state that it will be 0. And that's all it says. And up next we're gonna have constant multiple. In constant multiple rule, it's stated that when there's constant and let's dive in with the examples of constant multiple rule. Say for example we have the derivative. The derivative of say 5x this will state that the 5 as a constant here will be stayed, and we need to find the derivative of x, and in this case the derivative of x will be 1, and simplifying that we get 5. Another example we have is 4x squared, and solve that right down there. Y prime equals, so if we do that using constant multiple rule, like just like earlier, we leave in 4 and then try to find the derivative of x squared rather. So the derivative of x squared is going to be 2 as we bring down 2, and we're going to talk about this later to power rule up next, so tune in. So the derivative of x squared, bring down 2 here, the x here, and we're gonna minus 1 to the exponent, so 2 minus 1 is gonna be 1, so that will stay as x. So simplifying, we get y prime is equals to 8x. Now we have power rule. In this case, it is stated that the derivative of this function with the respect of x is equals to n mu raised to n minus 1, which is said as earlier, the exponent was bring down next to the x or whatever variable this one is, and exponent will be negated by 1. So if you have an example here, say you got 5x cubed, and we try to find the let's not have, let's just say that one. Let's say try to find derivative of this function over here. So by following this formula, we're gonna have 3, then copy the x, and then we negate 1 to the exponent, so 3 minus 1 is gonna be 2, so I'll now gonna give us 3x squared. So that will be our final answer, and that will be power rule. Up next, we have addition and subtraction of derivatives. This looks like this. So this is the sum and difference of derivatives. Let's go straight to the examples here. So example, we have 4x cubed. Let's say it's plus, and 6x squared. So what we're gonna do here in sum and difference of derivatives is we're going to find the derivative of each of these two terms, and just combine them. Basically, let's start with here 4x cubed, which is gonna represent f of x, and 6x squared is gonna represent 6. Start by f of x here. So the derivative of 4x cubed, just like what we learned earlier in constant multiple and power rule, we're gonna leave the 4 there, bring down the 3, copy the x, and minus 1 to the 3, and that's gonna give us 4 times 3, so the 12x, and 3 minus 1 is equals to 2. So that's our f of x. The f prime of x is equals to 12x squared, the first derivative in this example, plus the g of x, which is the 6x squared. Just like earlier, we stay in 6, pull down the exponent 2, copy the x, and 2 minus 1, n minus 1, 2 minus 1 here. Simplify. 6 times 2, 12x. 2 minus 1 is 1. Invisible 1 there, so that's gonna be x. So simplifying this function, we will end up with 12x squared plus 12x.